Hello engineers, welcome back to Engineering Design Simplified. In this video series, I will be solving tough engineering mechanics problems. If you want to watch more videos like this, please subscribe to my channel and press that bell button so that you will be notified when I upload a new video. Today's problem is a homogeneous hemisphere of radius r is placed on an incline as shown in figure. Assuming that friction is sufficient to prevent slipping between the hemisphere and the incline, determine the angle theta corresponding to equilibrium when beta is 10 degrees. Also determine A, the largest angle beta for which a position of equilibrium exists. B, the angle theta corresponding to equilibrium when the angle beta is equal to half the value found in part A. In this problem, a homogeneous hemisphere is placed on an inclined plane like this. This angle is beta, this angle is theta. So in this problem, first portion of the problem is we need to find when beta equal to 10 degrees for equilibrium of this hemisphere on this inclined plane, what is theta. So the second portion of the problem is the largest angle beta for which the position of equilibrium exists, and that means the beta max we need to find. So the third and final portion of the problem is if beta max is half the beta max, beta is half the beta max, then what is theta? So let us see in the coming slides how to solve this problem. From this diagram, let us see that let us call this point of contact A and the center of the sphere is C. So the distance between A and C is the radius of the hemisphere, that is R. So the center of gravity of this hemisphere lies at a distance 3/8 into R from this center along this line. So now let us see forces and reaction. So the weight of the hemisphere W is acting vertically downwards through this CG, and a normal reaction by this plane will be acting towards this direction perpendicular to this plane, and at the same time there is a friction force that F will be acting along this plane. Now let us assume x-axis lies along this plane and y-axis perpendicular like this. So this weight W is acting vertically downwards through this center of gravity, and N is acting perpendicular to this plane and F is acting parallel to this plane. So now let us resolve forces along this plane, that is x-axis. So x-axis we have the force F is acting towards this direction and component of W will be acting towards this direction along this blue line. Since this angle is beta, then this angle between this line and W will also be beta. Now let us write sigma Fx equal to 0. So the component of W along this plane, that is along this line, will be W sine beta, that is equal to F here. Now let us take moments about C. So this force N won't create any moment about C since it is acting through this point. Now moment due to F about C can be written as F into this distance C to A, that is R. So F into R. Now the moment due to W about C can be written as W into this distance. Since this angle is theta and this line is perpendicular to this line, so this angle will be 90 minus theta. So if this is 90 minus theta, then angle between this line and this line will be 90 minus theta. So this distance C to G is 3/8 into R, and this angle is 90 minus theta. Then this distance will be C, that is 3/8 R cos 90 minus theta, that is 3/8 into R sin theta. So the moment due to W about C can be written as W into 3/8 R sin theta, that is equal to F into R. Now let us substitute F from this equation, and simplification we get sin beta equal to 3/8 into sin theta. So this is the equation for equilibrium. So in the previous slide we have derived equation for equilibrium. Now let us see first portion of the problem. If beta equal to 10 degrees, now let us substitute beta equal to 10 degrees in this equation, sin beta equal to 3/8 sin theta. So from this we can get theta equal to 27.6 degrees. If beta equal to 10 degrees, then theta will be 27.6 degrees. Now let us see second portion of the problem. Here beta max, find beta max for equilibrium. So from this equation, beta will be maximum when theta is 90 degrees. So let us substitute that theta equal to 90 degrees in this equation. So we get sin beta equal to 3 by 8 sin 90. So after simplification, we get beta max equal to 22.02 degrees. Now let us see third and final portion of the problem. Here, if beta equal to beta max by 2, then find theta. So beta max we have seen in the previous slide, that is 22.02 degrees, and beta max by 2 is 11.01 degrees. So let us substitute this beta equal to 11.01 degrees in this equation. We get theta equal to 30.62 degrees. That's all for today's video. If you like this content, please like, share and subscribe. Thanks for watching.